Okay, it goes on to say if both the powers of the cosine and sine is even and non-negative, do this instead, all right? Now these are formulas that you probably should retain from Math 120, all right? So let me just, kind of review that with you, that, you should know the cosine of 2 theta can be written as 2 cosine squared theta minus 1. And that could be rearranged, by the way. And I'll point out the rearrangement that would be cosine squared, 2 of them, would be equal to cosine of 2 theta plus 1. And you divide 2 by 2, and what do you get? Cosine squared theta would be equal to cosine 2 theta plus 1 over 2. Now, someone says, what does that accomplish? It accomplishes something pretty important, by the way. You're taking something that's squared, and you're writing it something that's not being squared. And that's an accomplishment, by the way. So someone says, where's that guy right here? This guy's right over here, all right? That the cosine squared of x is the same thing as 1 plus cosine of twice x divided by 2. Let's do the other one, and then we'll talk about the recipe and working example, all right? So I'm going to say this one's done. Let's do the other one. So same thing. I'm going to write it down. The cosine of 2 theta can also be written as 1 minus 2 sine squared theta. And this can be rearranged. 2 sine squared theta, 1 minus cosine 2 theta, and then divide through by 2. You would get sine squared theta is equal to 1 minus cosine 2 theta over 2. And that's what's written right over here, all right? That the sine squared, again, what are we doing? We're reducing the power from a square to a linear, and we get 1 minus cosine of twice the angle, all divided by 2, all right? So I'm going to say, I understand where that came from. It came from Math 120, all right? So I got that part covered. So let's take a look at an example, and we have one right over here. And let's write it down. And what do they want to do? Well, I'm seeing cosine squared. I'm seeing it. But I'm seeing it twice. And what's their recommendation? To use those formulas. Let's write that down. So I get 1 plus cosine 2x over 2 times 1 plus cosine 2x over 2. Now I realize somebody's going to look at it and say, that you just made it worse. Not really. This will be 1/4. Then you can get 1 plus 2 cosine 2x plus cosine squared 2x dx. Well, you know what? I'm in trouble again. I have another square. I'm going to reduce that one. So 1/4, 1 plus 2 cosine 2x. And I'm going to write that square again. And how do you do that? Same thing I did before. So it's going to be 1 plus cosine 4x over 2 dx. All right? Wow, I guess I got to simplify that now, don't I? And I'm going to do, I'm going to get, I'm going to pull the 2 out on the bottom. It's going to be 1/8. And then what do you get? You get 2 plus 4 cosine 2x plus 1 plus cosine 4x dx. Let's keep going. 1/8. And then what do you get over there? 2 plus 1 is 3. And then I get 4 cosine 2x plus cosine 4x dx. Relatively simple integration problem. We'll check the key later, by the way. 1/8. You're going to get 3x plus 4 sine 2x over 2 plus sine 4x over 4, and then a plus c. I'm going to clean it up a tiny little bit, and I'm going to write this down as 3a of an x. Let's see, 8 times 2 is 16. It goes in 4 times, right? Sine 2x plus sine of 4x over 32 plus c. Let's get a red pen out, see how we did. I'm seeing a 3a of an x, sine 2x over 4, seeing that, sine 4x over 32 plus c. Things are working as advertised. Thank you.